So for this lab, this virtual lab, it's Waves Intro and it's on PhET. So this is how I put my frequency. So in the middle is 0.5, since there's 1, 2, 3, 4, 5. And then the max is 1, 1.0. Same here, 0.5 and 1.0. So let's say we put the frequency at 0.5 and the amplitude at 1. And then we press play. We let the water disperse itself until the waves are all the same. And then I can press pause. Perfect. Now that this is paused, to find the wavelength, you'll measure from two peaks. So if I put this here, I already did this, but if I pulled it out, I can measure to the next peak. Of course, this isn't going to be exactly perfect, but this is something you can do with kids. Kids' results will never be exactly perfect. They're not scientists, so I'm not complaining. So then my wavelength is 2.7 centimeters. Our wave speed for water is going to be per second. And to find the wave speed, you multiply frequency times wavelength. So that would be 0.5 times 1. And then, of course, you can make sure it's close to this 1 second, 1 second, because this isn't exactly accurate. You can't even see the tops or the bottoms, so the peaks and the troughs. So that's why I use the formula frequency times amplitude for wave speed. And then I plugged all of these results into my graph. And then I tried it at different things. So say we put the frequency at 1 and the amplitude at 0.5, and then we do it like this at 0.1, maybe 0.7, and I calculate all of those and I filled them into my graphs as you can see in my paper. So now let's move on to sound. Okay, so for sound, let's do the same. Let's do frequency at 0.5 and amplitude at 1, just to show. Then we press play. We let the waves disperse again. This time wave speed is going to be measured in milliseconds, as we can see. We're going to press pause. Amplitude 0.5, frequency is 0.5, amplitude is 1. We then are going to measure our wavelength again. We want that point there. We pull this out all the way to the other peak. It looks like it's going to be about 1.3.2. Of course, not exactly accurate, but something you can do with kids. And then you plug it in your wavelength, you plug in your frequency, your amplitude, and then your wave speed is in milliseconds for this one. And then we go on to light. So, as Rosie will explain later, light frequency is very different. It's in colors that the human eye can see. So let's say we put our frequency on green. So this is a green light radiation, and let's put the amplitude at 0.8. So right there. Then let's press play. Let the waves disperse. So as the waves are dispersing, I will explain. This is a femtosecond, and then this is measured in Newton meter. So light is always measured in Newton meter and femtoseconds. So then we're going to press pause. Again, our frequency, I just plugged in green, and our amplitude is at 0.8. So to find the wave speed for this one, I did use this handy chart. So let's play it again. This is what I tried to do, as kids would do as well. You try and pause it right on a trope. So this is about 1.8 femtoseconds. It's not exactly accurate, but it's exactly what kids can do. And then again, you'll put your top there, and you will measure to 2 points. And there you go. That's what you do for light. And then, of course, I would change the colors around, change the amplitudes, and try and just get a good visual of all of them. And look, they'll completely change based on your color. The waves look completely different, which you will be able to see in my chart. And yeah, that is what I did.